So looking at the major topics that we are going to cover, initially we will start with the basic theoretical stuff, understanding what is a supervised and unsupervised learning, what is a parametric and a non-parametric model. So some process that goes in terms of understanding the predictive analytics model. And after that comes our real exploration. So our first step is in terms of understanding the data. So once given, of course, you might have done this part in some of your other courses, like statistics courses or advanced statistics, whatever. So different kinds of courses you must have done these. So I'll give you a little bit of orientation to this again. But yes, in case you are very comfortable, we can move ahead further. But I'll give it in a kind of a framework where understanding some of the things is very much essential, especially before you build any kind of a predictive model or predictive analytics tools. Then exploring the data, right? Once you have observed the data using the understanding process, then we get into the exploration of the data. So what are the various data quality issues that you might come across, right? And so advanced data exploration, preparing the data so that the machine learning models can be applied on the top of it. So that is one more aspect. So wherever variable cleaning is required, preparation of the features is required, all these things we are going to take them up. And after that, we will be talking about the various learning mechanisms. So there are learning mechanisms like information-based learning, where we generally talk about decision trees, kind of tree-related algorithms. So your random forest and boosting. So all these algorithms come under the information-based learning models. Then we will look at the similarity-based learning algorithms, where the most common algorithm that is typically being looked at is the k nearest neighbor. So we will understand what is the conceptual aspect behind each of these, what is that learning that each of these algorithms typically do. Then we go into a probability based learning. Of course, the sequencing can be slightly different from what I have presented here, right? So here, understanding of the Bayes theorem and working with a naive Bayes model. So these are some of the important algorithms that fall under this category. Then the error-based learning, which is the most common form of a learning, where you look at simple linear regression, multiple linear regression, and all the other lasso, ridge, which are some other improvisations on the top of the basic regression model. And along with that, we would also be looking at other predictive learning models like neural networks, support vector machines, etc. So basically, if you look at the whole bunch of machine learning algorithms, especially used for a prediction purpose, are typically covered as a part of this. And along with that, so these are all a part of the supervised learning. We would also have a module, I forgot to include it here. We would also have a small module on unsupervised learning, right? So wherein we would be covering typical two major kinds of problems. One is called as a clustering problem. You might have done this clustering in your advanced statistics, but yes, here again with some small modifications, we would be taking it up. And along with that, we would also be looking at association rule mining. So actually here, I'm planning to do the clustering in the context of, I would be doing this clustering in the context of text mining. So that a little bit of introduction to text mining is also being done. All right. Then the model evaluation. So different kinds of models and the evaluations of different kinds of models we are going to do. Right. So then, yeah, so that is what is the major topics that we are covering as a part of this course. So which means by the end of this course, you should have a comfort in terms of the computational capabilities, inferential thinking, and practical skills for tackling core data scientific challenges. Then you should be able to use modern analytical techniques and develop skills for importing, exporting data, cleaning, visualizing, analyzing any kind of complex data set. Then you should be able to understand the computational foundations for predictive. So basically, you know what the outcomes are. So at the end of the day, you should be comfortable in providing solutions. You should be able to solve some kind of small problems. Given a data set, you should be able to given a large data set, you should be able to do some kind of analysis on those data sets. to be able to develop the ability to build and assess database models, blah, blah, blah. So this is there as a part of your course handout as well. Right. So at the end of the day, you should be comfortable in terms of building various models and making an assessment of various models. And finally, come out with a solution for solving a particular problem. Then coming to my last slide before I open it up to you. This slide. Yeah. So there is an in-class experiential learning. As I said, my every class will not work with slides. My classes will work with Python notebooks. Right, slides are only used for scribbling. I see Yogesh Kumar making a comment. Since you write a lot on slides, will the PPT that you will share in the backpack have your writings on them? First of all, only today I have. I'm writing this. I mean, I have the slides. First of all, after that, the composition of the slide will be very limited. But yes, whatever the slides that I share in the backpack, they will have my writings as well. So, which means you can, if you want, you can simply delete them just by clicking on it. You can very well delete them. So I mean, from the next class, once we start the practical, it is like a blank screens that I typically put so that I can write on them, right? So all the models highlighted, I'll go through all the questions because I'm not able to follow both of them parallelly. So once I finish this slide, I'll open it up to you for feedback and pluses, minuses, etc. Then we will definitely we will modify wherever required, and if that is done, then we'll get into the actual class. So all models highlighted in the content structure will be demonstrated live in the class. So all the models will be executed live. Probably I'll take a small data set because executing these models on larger data sets may be like time consuming, and within the class time, it may be difficult to execute them. So I will be working on slightly small. Again, small means around 1,000 to 1,500 kind of records. So that is the size of the data set that I would like to work with rather than a few millions of records. Again, the infrastructural issues might typically crop up. So just to understand the concepts, I will always be taking the data from public repositories like Kaggle, UCI repository, or any government repositories, etc. And in case you guys come across some good data sets, we can even consider them as well. So that is our in-class. In-class is completely building the models and trying to learn concepts within the model or within the practical. Basically, if something can't be practically implemented, why do I need to learn it? Right? Obviously, within my scope, I'm again restricting. I mean, if I don't know how to apply a particular method, then probably I'm not taking it just for the sake of teaching a chapter. So basically, we will try to learn a concept within the scope of practitioner, within the scope of a practical implementation. So for this course, the practical implementation is primarily the prediction. So prediction of creating predictive algorithms, predictive modeling algorithms by looking at the data sets. And your experiential learning assignment is also on a similar note. It is a 25% one single assignment, but of course it would be a comprehensive assignment for the entire 25% weightage. So you will form groups. So this is like a group learning assignment, but again the group size is not more than 3 members, and you will take a very comprehensive. You can fill up some kind of a data from Kaggle. Initially, you will have to create a problem statement for me by looking at the data, and you should try to solve the problem for me, right, by using various mechanisms. So I mean, most of the times I would prefer giving a data, right? But again, if you say you have some specific data from your organization which you can work upon, you can very well do that. And so the advantage is when I give a common data, the evaluation is also primarily based on the scores that you are typically getting, the kind of accuracies that you are able to generate. So it's like a simple competition that happens elsewhere as well. So we will try that. All right. So that is the experiential learning assignment part of it. So basically, it has to be a learning with fun. So you can take some kind of a data set and we can work on it to get the best possible results on that as such. So this should also help you to participate in some kind of competitions on Kaggle, etc. Once you are comfortable with this particular course. Okay, so now let me look at some of the questions because I'm done with the basic introduction. And after that, I think I can come back to the typical coverage of the course. Okay. Okay, Devraj, will there be any class on Python? So, I mean, basic class on Python, I'm not going to have it. But typically what I suggest is, if you are able to install Python, and so basically I would be using, again, no specific importance, but I would be primarily using Jupyter Notebook for writing the Python course. But again, so this requires probably you can do the Python installation, Anaconda installation. So I hope all of you have Python on your machines, but in case you don't have Python, one way is you try to take the help of some of your friends who have already installed. Or second thing is you can simply go to this Anaconda. You can search for Anaconda Python installation. Just download it and install it with all the defaults. Don't change anything. With all the defaults, try to install it. And once you install it, you can run the Anaconda, and you will have to install Jupyter Notebook. So I would be writing all my codes in the Jupyter Notebook, and I will be sharing the code with you most probably before the start of the class itself, so that you can have something to practice parallelly with me or immediately after the class. But the only thing is, during the class, I will be making some small modifications depending on the discussions that we have, which means there might be another version that might come out of that. But typically, rather than writing the codes in the class, I would be typically sharing with you the pre-written codes, so that we can spend time in the class discussing the interpretations of the same. Right, based on the results that I get, we can keep discussing the interpretations of the same. So wherever some complicated Python code is there, I would definitely explain that Python code. So basically, this is also like learning Python through example, rather than trying to start the basic Python saying 1 + 2 = 3. The typical Python learning starts from the basic arithmetic operations, etc. So rather than doing something like that, we will try to learn within the context of our machine learning itself, in case some of you are not that comfortable with Python. Okay. So again, if you have any follow-up questions, I suggest that you should post them, because today's class, I always reserve my first class for expectation settings itself, right? If I'm not going to cover something, I will explicitly mention it here itself. And if I can, you will get a lot of time to work on it, right? If I scope to cover lot many topics, that is what I have been experienced. Even if you are comfortable with R, you can still as well, right? Because our objective is executing a problem, solution to a problem. So the predictive analytics should be the focus here. R and Python should not be the focus. Using Jupyter Notebook, I would also share the apart from the IPython notebook, Jupyter Notebook, I would also share a simple Python file. Also, for every class, I will share the Python file as well, which means you can copy that code into PyCharm or probably a Colab of Google or many places. There will be very small modifications that are Jupyter Notebook has advantages, right? Because I would be sharing even if you want to use Spider, or I don't know what all the various IDEs that are there, because they are all not so important for us. And let me tell you, some of you may be very good programmers, might be coming from an IT industry, etc. I may have to really confess that I don't come from that programming background heavily, though I had worked in the IT industry, or though I come from the computer science engineering background, but I did not get a chance to work, or I haven't chosen to work in the programming area at any part. So my working on all these things is primarily from the perspective of communicating the subject clearly, because if I do a practical demonstration, explaining the subject will become more easy. That is what I strongly believe in. So to that extent, it is very much possible that the code that I am writing may not be as sophisticated as some of you might very well feel, because there might be an issue with respect to the effectiveness of the code in terms of the time it may take to execute, right? Or some kind of can it really bear the load? So there could be a few non-functional related elements that can very well be there, lacuna as a part of my code. So if someone can very well improvise on it and let me know the areas of improvement, even that would be a kind of an opportunity for me to learn from you guys as well, especially the programming side of things. Then there is a question, does it cover neural networks also? Yeah, I would be covering it, but very preliminary to the area, to the aspect of multi-layered perceptron. So I would not be getting into the recurring neural networks and right, concurrent neural networks, wherein they would all be covered as a part of deep learning, and we are not having deep learning as a part of our scope. So the basic introduction to artificial neural networks is what we are covering as a part of this course. Okay, then Jatin, is there any group created which I can join? Right now I haven't. What I'm planning is I will create one WhatsApp group, and I will put that link in the backpack, right? So you can I'll invite you to that group, and you can actually I'll send you the link for that group. You can join that group using that particular link. So once we are done with this class, I will do that exercise. I'll put it in the backpack, and you can join there. Okay, so I don't know, I haven't used Telegram till date. I'm really not comfortable. I'm not that I'm not that heavy on gadgets and social medias, etc. I mean, I use LinkedIn, but apart from that, I don't use much of the other social media. So WhatsApp, yes, we can definitely be there on that. I have been using it and I'm comfortable with that, but I haven't used Telegram till now. So again, I am not that comfortable with that. So I would be creating a WhatsApp group and I'll be sharing the link with you. Okay, screen not visible. I don't know. Do we cover LHS algorithm? Could you elaborate? Okay. Then also along with that, free to use anything, because after that you can copy it into any editor of your choice. Okay. Walk with the fundamentals of machine learning for predictive data analytics. You can, or probably some of you can take the first one, some of you can have the second one, right? To get into the more, it's always better to look to my code as well as BB Aditya. This is, don't want to install anything, I think you can very well use a Google Colab. So a Google Colab loads it is different from the way in a Jupyter notebook I load it. So those things, small errors, you can always Google them out, or probably this group is a very big group. So we might be having experts from various specializations. So many people in this group itself can provide solutions to the same. Okay, I think this course is extension of Foundations of Data Science course we had in the last semester. So you, Vineet, are you from MSc Business Analytics? I think some of them had the foundations of the batches don't have it. Okay, I have this Python book. Will it? You can let me know. That should be fine. But practical language is in a great detail from a pattern as well. Some of you may find it difficult. That will ease in my. And do we have ARIMA model, NLP, or deep learning concepts covered? ARIMA models are typically covered in my other courses. I mean, actually, I don't know how many of you take what other courses, but typically I am covering the ARIMA. You will be taking those courses are to show you if the data is a reviews or some kind of a text data. Concepts, not much. It is a group of 5. I don't mind. Probably 2, etc. So otherwise, I have a group of 5 as well. Of the 5 members, probably this is uploaded to Kaggle, basic solutions on the top of them using R or Python, and it is very fresh data set that is uploaded in related to a project which is slightly more sizable in nature, so that you can work in groups of 5 rather than groups of 3. I'm very much fine with that, Yogesh. But yeah, you can, or then I may have this experiential learning only for 15 or 20 marks. So I will have to look at that. If you would like to explain some kind of potential models as a part of this grants courses as well as potential data in the Kaggle across the various cleaning on the data set, so defer to backpacks, right? Is definitely required. So that's the reason. Anything that is not there, pretty new to programming languages at all, get to read. It would. I am from a non-software background. You would like to cover, right? In case you are not comfortable, then probably we'll look at an alternative also. I hope that should be fine, Pankaj. At the end of the course, I want you to be basically comfortable. So whatever the few basic lines of code we were able to write, at least whatever I'm writing in the class, even if you are able to replicate that, that is also a great achievement for us. All right, so look at it from that perspective. I'm not going to give you any finance data set here. So no domain knowledge for the assignment. Course, could you help? Okay, a few important lines of code for the next class. I'm going to, right, I hope you can we use Python enough? We have already, for those who are better refer to your one good book. I think some book of, the Indian edition is the best of our course. So, well, right, many and even prefer doing. Do we need to install? Very free to do the environment for any. So let me tell you, as I told you, in some kind of a tools in the new generations as well. Looking like 3 XGBoost. I use WhatsApp for some time to get, right. There would be a lot of support of it because at the end the learning maximization is what of the gradient boosting machine, which is like late. But once I look at it, I must. Then Sharat Kumar, I'm already taken care of. Actually, just as a talk about where it will take, how comfortably we are. I'll take your opinion. What you really want? We will be doing some. The whole project would, right? I suppose. So we'll do that. We'll try it. Okay, there. But I'll check if I can go for reduce the weightage. Right? We will go for because it backfired way in the output. I have shared the entire. I have 2 or 3 days before that. So there are specific questions, right? 5 important observations. I make around 20. I will be giving semester. I have given it of the exam. The questions would be given only on the day of the exam. Okay, so I think this answer. Question: do we have? On time, and any of my learning this may be difficult, so that's okay. Midsem %. I mean, most of my midsems are like midsem is 30 and endsem is 45. But I would also like to consider this. See if I can take the increase the weightage of experiential learning to either 35 or 40%, and try to keep 30-30 for midsem and comprehensive. I can even think of this proposal, Yogesh. I'll get back to you on this. I'll check internally. So I think some of you are suggesting Telegram solution for WhatsApps. So I don't know. You can some of you can tell me what should I do for that. In case I'll look at it and I'll install it. I want to spend too much time on that. this. The recorded lectures are going to be there just like any of your other, and it is good, fair enough, friendly. I will also try. I don't know, some other names are coming. Probably I will stick to one. Right, it's in the course. Okay. Okay, probably let's see if required, we'll go for one. For all the finance related stuff, we'll download the data directly from, because majorly it's not finance that we are handling here. Okay, and setting the expectations pretty clear. Excited to learn more through practical experience. That's really great. Handout is sufficient enough for low like this. Okay, Telegram also has polls, even anonymous polls. So I'll definitely look at that because probably after this class today I have back-to-back classes until 3:30. So I think probably after 3:30 I'm going to look at some of these things, and I'll try to create one group today itself. I'll try to work on it. For two subjects, 35 and 30 weightage. So what is this for 35 and 30? This is for the experiential learning you are mentioning. So if experiential learning can be taken to 35, I would always prefer that. 45 marks should be able to complete. There's only 2 hours, hence 45 marks question should be able to be completed within that time. Okay, we'll see if it can be reduced. Sharing PDF of output beforehand, very helpful and preferable idea. Yes, I'll do that, because at the end of the day, my intention is to ensure that you are doing the learning. So yeah, I can do that. You discuss among yourself, but as long as you are able to answer my questions, that should be good enough, right? Because just by knowing the data and the output may or may not, I mean, unless you know how to interpret it, it may not solve the purpose. If you prefer, I can create a Telegram group. Let me learn, right, Yogesh? I'll try to prefer, but yeah, if you can include everyone, that should be fine. But yeah, even that would be a small learning for me. Let me try it. EL plus quiz 40, midterm 30, compre 30. Okay, I think if that proposal is fine with many people, let me see if that is feasible from our BITS perspective as well. So if that is feasible, I don't mind going with that as well. WhatsApp has group member limiting. Yes. We'll cover data visualization. No. So we don't have a data visualization as a part of this course. We have a separate course on data. Okay. From the perspective of understanding that the Seaborn package, that part of data visualization is predictive analytics. So difficult because things recorded videos going to cover. I'll try to share the code sometime. I mean, again, for this course, this can help you out. Otherwise, I'll just we will see how we are able to move forward. And yeah. Set for analysis, no, going to deal with time series analysis, then probably I would cover that aspect. I'll take the Indian equity market data only and I'll cover it. But again, there are a lot of people, a few other courses that are there. You must be having, you will choose those electives, and right. So I think the machine learnings could be very much available on YouTube, right? So you would be covering in the class, and basically you can go through those YouTube videos as well. For up to 8 members, we have proved everyone's contribution while presenting. So I mean, does not justify that. So I would go. We really appreciate your support. See, courses. So probably if you can take those electives, because you have a. So I don't want to understand to share a sample PDF and a question paper. The output, that is what would be the PDF. Please touch base on predictive analysis in supply chain management. I would be taking supply chain analytics elective. He or she would be touch basing on those things in my class. I may take a very related data, and you can, yes, I if that elective. You can check all the class. And all over a period, we can get the clarity on that. We have close to that. When we are talking about analytics, the analytics is all about drawing some kind of insights from the data, right? Analytics is all about drawing insights from the data. So whatever the data you have been given, either the data would be a collected data for a specific purpose, or the data could be an available data which has been collected for some other purpose. So you can have the data in various formats. You can have the data in a very structured tabular kind of a format, or you can have the data in the form of a running text, or you can have it in the form of images, right? You could have it in the form of audio, video, etc. So we have data in various formats. Now looking at this data and trying to give some kind of insights from the data. Now what could be the kind of insights? So, is my screen not visible? I'm sharing. Okay, it is visible. I think someone are able to see it, so probably it should be a problem for others. So you can try to refresh the screen. Okay. So yeah. So from the data that is typically belonging to any of these categories, we are trying to draw some kind of insights from it. So though most of our class would be on this data, the structured tabular data, but in some kind of scenarios, we would I would introduce you to this text data. And I would also introduce you to this images data. But again, They are like very, very brief for one small use case or something like that, just to give you an introduction to each of these. But primarily all our models, because most of you should get comfortable at least with this dimension to start with. So I would be working with the tabular related data, right? And so our objective of analytics is to draw insights from the data. So drawing that insights is, initially it could be as good as your descriptive. Your analytics could be more and more descriptive in nature. So these are the things that you might have covered a little bit as a part of your statistics or quantitative methods kind of courses, right? So where you try to do some kind of, so in descriptive, you only describe the data. You only describe the historical data. So the descriptive could come in the form of some summaries. So you try to do some kind of summaries on the data. That summaries are sometimes basic data visualizations you would like to do, just to try to understand the data, right? Descriptive is primarily you create a kind of a report on what has happened. What has happened is what a report that you are creating. So we would be doing that in the part of this course also for one session or so, because at the end of the day, unless you understand the data, you cannot give some you cannot actually use the data for the prediction. Then once you are knowing about the descriptive, you can also do some kind of a diagnostic analysis. So the diagnostic is primarily coming from the perspective of your inferences. So inferential analysis also you can very well call it. So the inferences you are making based on the data. So these inferences probably are more statistical in nature. And if you remember, as a part of your statistical courses, you would have done some kind of various tests on the data, etc. Various statistical tests, whether it is your t-test, f-test. I hope that you are all comfortable doing all these various tests and making some kind of inferences from the data. And the third aspect that is the focus for us is making some kind of predictions. From the data, right? Once I make some small inferences, trying to build the relation here, the inferences are primarily the relationship between two variables, etc. Is this a significant relationship or is it an ignorable kind of a relationship? So once I build that, then I would be interested in building various predictive models, because that is what is very, very essential. The learning from the statistics is always like, reporting is a very small aspect for me, but more than the reporting, I should be able to create some kind of predictions on the data. And that is where we would be using the predict. So this is the part that is the scope for our current course. But of course, some of the predictive models you must have already used earlier, right? You must have used a simple linear regression or a multiple linear regression, or I'm not sure whether you have used a logistic regression, etc. But yes, these are some of the predictive models that you might have already used in your earlier courses as well. But we will be building on the top of them and see how predictions may be in some cases better when I'm going for the other forms of learning models compared to these simple linear regression or a multiple linear regression kind of model. And then there are a few important other things in terms of prescriptive analytics, right? In terms of prescriptive, it's more like a solution building where the optimization of the parameters, etc. So which is actually coming in the world of a sophisticated form of your operations research, etc. They are coming under the prescriptive analytics. So as a part of this course, our focus is primarily on this predictive analytics, though we would be using a little bit of this descriptive and diagnostic also, but the major focus of this course is on predictive analytics, generating some kind of prediction. So in this predictive analytics, or in the whole world of machine learning, we typically have problems that can be classified into what is called as a supervised learning and unsupervised learning. So we have supervised and unsupervised learning. So the supervised learning is where the actual prediction part comes in, right? In the whole world of machine learning, probably let me not call it predictive analytics here. In the whole world of machine learning, so the problems can be divided into a supervised learning problems and unsupervised learning problems. Though we have a few other categories as well, where we call semi-supervised learning, or we also talk about reinforcement learning. So reinforcement learning is a slightly different world, right? Probably all your current chatbots and all these embedded kind of applications, they use all the reinforcement learning. You talk about self-driven cars, etc. They are all the autopilots or unmanned vehicles, etc. They all come under the reinforcement. They use the reinforcement learning because there is an interaction with the external environment, and based on that there would be a kind of carrots or sticks, and based on that the overall end-to-end solution is visualized. But to go to that, you need to be very much comfortable to use either both the supervised and the unsupervised learning algorithms. So the supervised ones typically is the place where the actual prediction is going to happen, right? So basically it is like you would have your input variables as well as output variables from the historical data. your historical data that you are using will have some input variables and will have one output variable. And your intention is to learn the relationship between these two. So how do you learn? There could be various ways of learning. So some people may say, I will mug it up. Some people may say, no, I will remember in a very different format. Some people may say, I will try to I'll try to read here and there, right? And based on that, I will try to make some kind of sense out of it. So there could be like, the learnings that different people do could be different. So the relationship, there is an output, and in line with the output, the input needs to be understood. Input is some columns of data. Output is one single column of the data. That is our target. So that is the reason in this world, inputs are typically called as features and outputs are generally called as targets. So we would try to build a relationship between the features and the targets. So that is the objective. And once we have built a good relationship, it means I know what is the relationship between the targets and the features. Targets are generally unknown kind of things, right? Target is something that is unobserved or at this point. At this point, I don't know. So unknown or unobserved. And features are something for who the value is already known now. Value is already known now. When we are trying to build the model, features, all features should have their value known. Whereas for the targets, their value should be unknown. That is when I am trying to predict them. If I already know that value, why should I predict it? The only thing is I don't know anything about it. I don't know what would be the value. So that's where I'm trying to predict. So all the supervised learning algorithms that we are going to look at, they would typically be doing some kind of a prediction. So probably we would be using different kinds of algorithms, right? And this prediction also, there could be primarily for this prediction, the most common problems are in the prediction, there are two most common problems. Again, I'm always going with the most common. So there are classification problems and there are regression problems. Classification problems are like, I am trying to do the prediction of a category, right? A category could be a good, bad, or my output is like yes, no, right? So those kind of categorical, not necessarily binary. It can be any multiple categories also, but I'm actually predicting a categorical variable. My output is a categorical variable. My target is a categorical variable. Whereas in a typical regression problem, my output is a numerical variable. In a regression problem, the output is a numerical variable. So don't get confused with simple linear regression and multiple linear regression that you have used, right? Because they are only one such kind of regression problem. So there are various other regression problems, and the research in this area is growing leaps and bounds. So some new algorithms can keep coming quite often. So that is my second. So we are going to deal with a wide varieties of algorithms that fall under the classification as well as the regression. Then the other set of problems the machine learning is going to address is an unsupervised learning. So in this unsupervised learning, there is nothing called any kind of a prediction. We don't do any kind of a prediction here. We primarily look at, so which means you don't have an output in the historical data. All the data that you have is the input only. So there is nothing called output because I don't want to link it to anything. So it's an input only. So what is that we do in this? We only do pattern identification. You try to explore. So you try to identify different kinds of patterns in the data so that you can use that for some purpose later on. So the major part is pattern identification. So the pattern identification, one of the major examples that we talk about is the clustering, right? Or you will talk about what is called as dimension reduction. Probably in some of your courses, you must have used something called a PCA. So these are some of the things that fall under the pattern identification kind of aspects. So they go under the unsupervised learning algorithms. So we are going to deal with these things as a part of the current course. PCA, yeah, I'll take up the unsupervised learning. So within that unsupervised, I'm going to look into that. I mean, again, there would be some limitation on how deep we go into each of these aspects. But yeah, definitely we are going to cover it. And based on the questions that come up, I will see if I can cover that later, or sometimes, I mean, we can have some extra classes to go a little bit more deeper, or I can actually give you another reference to that as well. Yeah, I can typically cover the PCA also. I mean, we have a very simpler way to understand. Yeah, dimension reduction. PCA is one method of dimension reduction. So to answer your question, PCA is one method of dimension reduction. We will talk about various feature selection methods also here. So which are the machine learning driven dimension reduction methods. PCA is purely a statistics driven dimension reduction method. All right, and it's a linear method. So semi-supervised learning is as simple. I mean, you have your data where for some of them you have output, and for some of them you don't have the output. For some inputs you have the output, for some inputs you don't have the output. So what you typically do is, initially you take the supervised, you apply the supervised learning on the data where you have the output, and you would typically try to do the projection on the data where you don't have the output. And the other thing is you would also do an unsupervised learning on those data where you don't have the output. by doing some kind of cluster analysis and try to compare the predictions that are coming out from the data. We are using the supervised learning, and based on this comparison, based on the accuracy that is being generated by the unsupervised learning algorithm versus the supervised learning algorithm, we will come out with some kind of combined model building. So I'll explain. I mean, I think we are not covering, but again, I'll explain it in a little bit more detail once we do both of them.